is less than predicted by their age. Again, notice the word predicted. Again, the relationship. There's a relationship, and we understand that, between height and age. So what you would do is you say, okay, I have a young person here. The person is 8 years old. I'd plug in 8 for x. Whatever the slope was, I'd multiply. I'd add the b and come up with a y. That would be the critical height. If their height, this individual's 8-year-old's height, was less than that, they would qualify for this assistance. If they were equal to it or greater than it, they would not. So there's sort of a rationale. And let's take a look at what this kind of inequality looks like. Let's look at an inequality with numbers. Y is less than, and let's use 5x plus 3. Why use that? Because I wrote it down. Now, what does that mean? Let's talk about what it means. And then in this lesson, we'll begin to look at how we can graph these things. And later on, we'll talk about how we're going to use these things specifically. Okay? What does this mean? It means you give me an x, for example, 2. Good. All right. 2, if 5 times 2 is 10 plus 3 is 13, this says when x is 2, y has to be less than 13. What could y be? It could be 12.98. It could be 12. It could be 2. It could be 0. Negative 5 million. But it has to be less than 13. Okay? What if x was negative 1? Okay? 5 times negative 1 is negative 5. Plus 3 would be negative 2. When x was negative 1, y would have to be less than negative 2. Negative 2.1, negative 3, negative 17, negative 400,000. But less than negative 2. That's what we mean by an inequality in two variables. It's a linear inequality because this part over here is really part of a linear equation, mx plus b. Okay, so we've seen a practical use for it. This is what we're talking about. Now we're going to try to see how we can graph these things. But just so you won't get confused, let me erase what's on the board here because that might confuse you as I walk back and forth by that. Okay, what we're going to do is we're going to look at steps in graphing a linear inequality. And if you obviously been watching these tapes, you know I love steps. I love a step-by-step method because once you've got the method, you'll know how to do the problem, as opposed to just looking at it and saying, I don't know how to do this, I'm confused. We start with a very specific step. And what we're going to do is we're going to take a inequality and go through the steps. So let's take a look at the first visual. The first visual says the first thing we want to do with an inequality is get it in mx plus b form. That is, we want to have, just like we had before, y is less than mx plus b, y is greater than mx plus b, possibly y is less than or equal to mx plus b, or y is greater than or equal to mx plus b. So in this visual, the original inequality was 2y minus 4x is greater than 6. That is not in mx plus b form. So what we do, we want to get rid of the x term. We add 4x to both sides. We get 2y is greater than 4x plus 6. We then divide by 2 because we don't care what y is greater than. We care what, we don't care, correct myself. We don't care what 2y is greater than. We do care what y is greater than. And y is greater than 2x plus 3. We now have this in mx plus b form. Let's pause a moment because I want to mention something that will come up later on to remind you what we said. Anytime you have an inequality and you multiply or divide both sides by a negative, remember we switch the inequality. We talked about that. If you forgot why, find the proper chapter in the tape, go back, look at it, and I've explained it before. I don't want to take the time to explain it now. But I wanted to remind you about that because it will come to play when we have to divide both sides by a negative. Okay, now what do we do? We have the inequality. In this case, was y is greater than 2x plus 3. Let's take a look at the second visual. It says lightly in quotes, lightly sketch. That is, take your pencil, writing utensil, and lightly sketch in the line y equals mx plus b. In previous lessons, we've looked at how to graph a line given the equation. You should be able to do that. Now, you'll notice on this visual, it doesn't look very light. But again, how do you make a light white line? Well, the point is that just visualize that as being a lighter line. The reason we do it lightly is because we will be looking at some aspect of the inequality to see what that line really should look like. But you'll notice that the line goes through the y-axis at 3. Why? Because it is the graph of the equation y equals 2x plus 3. 3 is the y-intercept. You'll also notice it goes through the x-axis at negative 1.5 or negative 1.5 if you like. And the reason for that is if we plug in y equals 0 and solve for x, we'll get x equals negative 1.5. So we can verify this indeed is the graph of the line y equals 2x plus 3. All right, now we have the line. But remember, our goal here is to graph the inequality, which is not a line. Let's look at the third visual. The third visual tells us what to do to draw in the line, because it says if the inequality contains equal, greater than or equal to, or less than or equal to, we draw in a dark line. We darken in the line to indicate that the inequality contains equals. If the inequality does not contain equals, that is greater than or less than inequality, we dash the line. Therefore, if we had drawn in a solid line darkly before, and we now discover we had to dash in the line, we couldn't do that. That's why the first step says, after we get it in mx plus b form, the next step says draw the line lightly. So now in this case, we look at the visual and we see that y is greater than 2x plus 3, does not contain equals, so the line is now a dashed line, indicating that it does not include equals in the original inequality. We're not done yet. Why not? Because we haven't looked at anything but a line. Even though it's dashed, the graph of inequality is not a line. So let's look at the next visual, which shows us that if the inequality is less than or equal to, we shade below the line. If the inequality is greater than or equal to, we shade above the line. In this particular situation, since it was y is greater than 2x plus 3, we shade above the dashed line, indicating that we have a greater than situation. The greater than because it's shaded above the line, and it's only greater than, not including equals, because the line is dashed. Now, what I'd like to refresh your memory about in terms of the shading is, remember we were talking about the used cars. And we talked about the cars that the points that were above the line. And we said, why are these points above the line? You said these cars had greater value than indicated by their age. And we talked about possible reasons for that. The key thing, again, was that their value was greater than indicated by their age. The line we had drawn was their value as a function of their age, a linear equation. The points above were greater than. The points representing cars below that line were cars whose value was lower, was less than expected based on their age. So it should be easy to remember. Greater than is above the line, we shade above. Less than is below the line, we shade below. Okay, the next thing we need to do, of course, is to check. Remember, everything we do, when we can, we check. So let's look at the next visual. We have the shading and the dashed line, and it says negative 2, 2. That's a point, and that point is indicated. That point is in the shaded region, which means it's part of the solution. Remember, a solution point here would be an x and a y that works. So let's plug it into the original inequality. Not into the y is greater than mx plus b form, but the original inequality, 2y minus 4x is greater than 6. We plug in 2 for x, we plug in 2 for y and negative 2 for x. We get 4 plus 8 is greater than 6. Well, certainly 12 is greater than 6. So we know that that point works. Could we check other points in the shaded region? Of course. If you were unsure about something, check points where you think there might be a problem. They should all work. But there are also points that should not work. Obviously, any point that is not in the shaded region. So the next visual shows us a point, 1, 2, which is obviously not in the shaded region. It should not work. We plug it into the original inequality, 2y minus 4x is greater than 6. We plug in the 2 for y, the 1 for x, and we notice that 4 minus 4, which is 0, is not greater than 6. It does not work. So a point that should have worked did work. A point that should not have worked did not work. We believe that our graph is the correct graph for the original inequality. Let's take a look at an additional problem. Obviously, when we take a look at an additional problem, it usually means we're bringing in something a little more challenging, but not too much, to emphasize how we do this. So let's look at the next visual. This problem has x minus 2y is greater than or equal to 10. Again, we start out with an inequality that unfortunately is not in the mx plus b form. So we got to change it to that form. So that's our first task. And it shows you that on the visual. We subtract x from both sides. Negative 2y is greater than or equal to negative x plus 10. We then divide both sides by negative 2. Y is less than or equal to. We divide it by a negative. When you divide both sides by a negative, you change the direction of inequality. So y is less than or equal to 1/2 x minus 5. We now have it in y is less than or equal to mx plus b form. What's the next thing we do? The next thing we do is to sketch the line lightly. And let's take a look at how we did that in the next visual. We have the equation y equals 1/2 x minus 5. Remember, what we're sketching is the line for the equation y equals mx plus b, which is the reason we want to do that first step to get it in terms of y is greater than or y is less than mx plus b. How did we graph this? Well, I think you should recognize we graphed it using the x and the y-intercept. Again, we got the y-intercept by letting x equal 0. When x is 0, y equals negative 5. Notice the point, 0, negative 5. The x-intercept is when y is 0. When y is 0, we have 0.